The James Webb Space Telescope, humanity's most advanced instrument for probing the cosmos, has disclosed yet another momentous revelation. The newly released snapshots of Pluto are remodeling every assumption we formerly held about this icy, celestial frame, unearthing insights both amazing and profoundly intriguing, once regarded merely as a dormant frozen sphere on the outskirts of our solar system. Pluto is now revealing itself to be far more complex and vibrant, with indicators of hidden activity, tectonic shifts, and complex chemical formations that defy cutting-edge comprehension. These paradigm-shifting discoveries have left researchers astounded and confused. At the center of this new comprehension lies Sputnik Planitia, the iconic heart-shaped region on Pluto's surface. What was once perceived as a rigid layer of nitrogen, frost now seems to cloak an expansive subterranean ocean beneath its icy crust, enveloped by thick ice layers. This massive reservoir of water could represent one of the most consequential breakthroughs in the quest for extraterrestrial life. Protected from the brutal conditions of space, researchers are now entertaining the prospect that microscopic organisms may exist in these concealed depths. Pluto's surface continues to astonish experts. Towering ice-capped summits reach elevations comparable to Earth's highest peaks, while large flat plains remain immaculate, indicating that geological rejuvenation occurred relatively recently. Such energetic phenomena had been completely unforeseen for a body once believed to be geologically inert. Heat from Pluto's core powers convection beneath its frozen shell, causing nitrogen ice to migrate steadily, much like cooling lava in a lava lamp. These occurrences reveal a planet that is far from desolate. As depicted in these unveiled snapshots, Pluto pulses with activity, despite its considerable distance from the Sun. It now shares company with other icy spheres and moons, such as Europa and Enceladus, all of which may harbor life beneath their ice layers. Water and organic compounds could interact in ways that ignite life's chemistry, even if no advanced organisms exist. The discovery of microbial life on Pluto would revolutionize our theory of habitability, demonstrating that life can endure in locales once deemed uninhabitable. Pluto's association with its moon Charon is remarkable in our solar neighborhood. Nearly equal in size, the two bodies exert mutual gravitational influence, generating internal heat and initiating dynamic changes on both worlds. Charon, too, harbors its own enigmas. Deep troughs and a distinct reddish tint suggest a shared foundation with Pluto. Material from Pluto's surface may be transferring to Charon, implying a chemical exchange that could carry life's essential ingredients. None of these extraordinary findings would have been possible without the James Webb Space Telescope. Its infrared vision allowed astronomers to peer beneath Pluto's icy exterior, unveiling features overlooked by earlier probes. Through the analysis of Pluto's surface and atmosphere, Webb has detected organic compounds and thermal variations, presenting a portrayal of a far more animated world than previously assumed. Pluto's atmosphere, though tenuous, is surprisingly complex, predominantly nitrogen with traces of methane and carbon dioxide. This forms a translucent veil stretching hundreds of miles above the planet. As Pluto follows its highly elliptical orbit, its fragile air undergoes dramatic shifts. When it nears the Sun, surface ice sublimates into gas, forming a temporary atmosphere. As it recedes, this atmosphere refreezes onto the surface, generating a unique cyclic pattern distinct within the solar system. These atmospheric cycles provide rare insight into planetary responses to extreme conditions. One of the most arresting features on both Pluto and Charon is the reddish streaks across their surfaces. These are believed to be coated with Tholen's complex, organic molecules formed when ultraviolet radiation interacts with methane in the atmosphere. Tholins not only impart the surface hue but also suggest prebiotic chemistry, an essential chemical pathway that could lay the groundwork for life. Researchers are especially captivated by how these substances might interact with subsurface water ice. Could these tholins serve as the primordial building blocks of life, transported into the underground ocean and mixing with other organic matter? This enchanting inquiry is one scientists are eager to pursue. Among Pluto's most groundbreaking revelations is the probable existence of an extensive ocean beneath its icy shell. This ocean, sustained in a liquid state through geothermal heat from radioactive decay at Pluto's core, may occupy a substantial part of the planet's interior. On Earth's settings such as hydrothermal deep-sea vents teem with life. If Pluto's hidden ocean provides comparable conditions, it could host microbial ecosystems or even more complex organisms. Unraveling Pluto's hidden depths could transform our perspective on where life can emerge, proving that even the most improbable locations can sustain vital activity. The dissemination of declassified photos and data from the James Webb Telescope has ignited widespread excitement and speculation. Governments, research institutions, now the public alike are captivated by what Pluto's interior may reveal about the broader universe. For decades, Pluto was undervalued as a mere world. However, these new discoveries underscore how little we truly understand about our celestial neighbors. As more data arrives, anticipation mounts around the many unanswered questions. The breakthroughs achieved by the Webb telescope represent merely the beginning. Future missions include orbiters and landers designed to examine Pluto in more detail. Such missions could confirm the existence of the subterranean ocean and provide the first direct evidence of life beyond Earth. Some have even proposed deploying robotic submersibles into Pluto's buried oceana. Monumental engineering feat that might rank among humanity's greatest milestones in space exploration. As technology advances, the aspiration of direct exploration of Pluto's depths becomes increasingly attainable. This pursuit could revolutionize our understanding of the universe in ways previously unimaginable. One of Pluto's deepest mysteries is how it maintains geological liveliness despite its remote distance from the Sun. Pluto generates enough internal warmth to power convection in its icy mantle and sustain a subsurface ocean. This heat likely stems from radioactive decay within its core, releasing energy over billions of years, coupled with tidal forces from Choron. This internal heat could explain Pluto's unexpected geological motions and ongoing activity. Subterranean sea. Even though Pluto lacks a robust magnetosphere like Earth's, still interacts with the solar wind in exceptional ways. These interactions strip quantities of its atmosphere, generating a stream of ionized debris drifting into space. The JWST has located uncommon magnetic and electrical phenomena surrounding Pluto, hinting at exchanges among its magnetic surroundings and the Kuiper Belt. These findings provide a rare window into how small celestial bodies and dwarf planets interact with their stellar environment. These revelations concerning Pluto are only the prologue. With missions concentrating on the Kuiper Belt and beyond, humanity is poised to explore the regions that Pluto has illuminated. New opportunities affirm that even the most distant worlds harbor memories waiting to be uncovered as technology progresses. The boundary between science fiction and reality continues to blur. From self-sustaining submersibles exploring frozen seas to crude missions advancing into the Kuiper Belt, Pluto reminds us that the universe is vast, enigmatic, and replete with awe-inspiring marvels, once brushed off as a frozen, lifeless rock. Pluto has revealed itself to be anything but normal. Its energetic geology, mystifying atmosphere, hidden oceans, and organic components challenge all prior preconceptions regarding the outer solar system. The James Webb Telescope's breathtaking photographs and innovative discoveries have catapulted Pluto from obscurity to the leading edge of scientific research. These findings caution us that mysteries still await. Even in the most remote corners of our cosmic neighborhood, looking ahead, Pluto emerges as a symbol of hope and curiosity. Its enigmas continue to inspire new journeys, cutting-edge technologies, and fresh inquiries into our place within the cosmos. Could Pluto harbor life? What other wonders might lie concealed beneath its ice? What can it reveal about our own beginnings? Pluto's saga is far from over. With each new discovery, we're reminded of the sheer immensity, hidden realms, and infinite surprises of the universe only we dare to investigate. What are your perspectives on the James Webb Telescope's revelations about Pluto? Do you believe it could harbor life or conceal profound enigmas we may not yet be capable of fathoming? Share your reflections below. Make sure to subscribe for more enthralling cosmic stories. The expedition to uncover Pluto's secrets has only just begun. With every unveiling, humanity's grasp of the solar system deepens. The James Webb Telescope has swung wide the door to a world we once believed we comprehended, only to discover that Pluto is a rich, dynamic domain brimming with secrets we are only beginning to interpret. These discoveries recalibrate our knowledge of Pluto and challenge our convictions about life beyond Earth as efforts persist to explore Pluto's surface, atmosphere, and veiled depths. Upcoming missions are set to address some of the most pivotal questions concerning its capacity to support life. Could the sea beneath its frozen casing shelter microorganisms, or perhaps even more sophisticated ecosystems? Pluto's bizarre atmospheric rhythms illuminate the formation of distant exoplanets. This enduring scientific voyage is crucial to resolving these and numerous other inquiries, with the potential to revolutionize how we perceive habitability on other celestial bodies, in tandem with the JWST's contributions. Other scientific instruments and exploratory ventures will improve our understanding of Pluto. Orbital spacecraft will offer fresh viewpoints, while landers and potential rovers may collect surface specimens. Later missions might directly verify the subsurface ocean, confirming that life can endure under the most extreme conditions. With the promise of learning more about Pluto's geology and atmosphere, forthcoming expeditions hold immense potential, just for this dwarf planet, but also for unveiling deeper cosmic mysteries. As technology matures, we may also witness the deployment of robotic submersibles beneath Pluto's icy shell, landmark in space discovery that could empower humanity to investigate one of the most distant, enigmatic worlds with unprecedented accuracy. Pluto's strange and unpredictable behavior continues to astonish scientists. Despite its isolation, it produces internal heat that drives geological and atmospheric processes. That heat, generated by radioactive decay in its core, helps explain the mobility of ice on its surface and the potential subterranean ocean. The gravitational interplay between Pluto and Charon further contributes to this internal heating. Tidal flexing sustains geological maneuvering. This vigorous investigative scrutiny into Pluto's geology and atmosphere is reshaping our understanding of planetary evolution in the frigid expanses of space. The fact that Pluto remains so active under crushingly cold conditions defies conventional knowledge, signaling that our understanding of what is possible beyond Earth remains profoundly incomplete. Propelled by the JWST's revelations, the ongoing exploration for life on remote worlds will define the next chapter of space science. Whether it is microbial life on Pluto, oceans hidden beneath other moons, or habitable environments beyond our solar system, the mission to define life's conditions across the universe is only beginning. As we expand our horizons and scrutinize new celestial realms, Pluto remains at the heart of scientific curiosity and thoughtful research. In summary, the revelations unveiled by the James Webb Space Telescope are merely the beginning of humanity's quest to decipher the cosmos. Pluto, once dismissed as a frigid, lifeless outpost, is now recognized as a dynamic, vibrant world teeming with unanticipated phenomena. As exploration proceeds of its surface, its atmosphere, and hidden seas, Pluto may yet unlock answers to some of the most profound scientific questions. Yet, its secrets remain far from fully discovered.